flown on a plane before? Okay, most of us. Good, 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 good. If you've ever flown on a plane, you might wonder to yourself, how do the pilots, when they're going through a cloud or at night or during inclement weather, how do they know where they're going? Today, we're going to talk about that. They use specialized instruments that are able to give them information about the aircraft's position without actually needing to see outside the cockpit. So, who am I to talk to you about this? Well, I am a private rated pilot currently working on an instrument rating at Parkland's own Institute of Aviation. I have almost 100 flight hours and have been working on this rating for about a year and a half now. So there's two primary systems that all these instruments run on. They are the piastatic system and the gyroscopic system. And there are 6 primary instruments that go along with those. So first, we're going to talk about the piastatic system. So there are 3 primary instruments that run on that. Don't mind the black box at the top. That is, that's just to cover up some identifying information for this particular aircraft. This is from one of the planes in Parkland's fleet. So these instruments, the piastatic instruments, use atmospheric conditions in order to show the pilot how information on how fast they're going and whether they're ascending or descending and how high up they are. These 3 instruments are going to be your airspeed indicator, your altimeter, and your vertical speed indicator. So the information that these run on come from the piastatic mast. So this is underneath the wing of the aircraft. It's this actual little piece here. So all that information for the piastatic system comes from that. According to a 2016 revision of the Pilot's Handbook of Aeronautical Knowledge, the pitot tube is utilized to measure the total combined pressure that is present when an aircraft moves through the air. Now, what does that mean in English? That basically just means that it is taking air from the front of the plane and from the back from 3 separate holes that are located here. One at the front for ram air for speed, one at the back for static air to get just the outside air pressure, and one at the bottom to ensure that any condensation or anything that gathers in the pipe can drain out of it without issue. So the 3 instruments that actually work on that are your airspeed indicator first. Your airspeed indicator is one of the most simple ones. It's literally just a tube that goes to a diaphragm that it pushes on and shows you how hard the air is pushing on it, and then shows you the speed that you are moving through the air associated with that. That one is rather simple, not too much to talk about there. The altimeter is significantly more complex. So it is they call it an aneroid wafer. All that means is it is just pretty much an air sac that is completely sealed. And as you go up in altitude, the static air inside the instrument will make that expand and cause the needle to move. Now, these are calibrated on the ground for the actual ambient pressure outside before you actually take off. According to Part 91.121 of the Federal Aviation Regulations, revised in 2022, these must be accurate within 75 feet of a field elevation. So, say we're taking off from Willard Airport in Champaign, over at Savoy. That airport is at 755 feet MSL, so above sea level. Our altimeter would have to read between 680 feet and 830 feet in order to be considered legal to fly. The next instrument is going to be, and the final one for the pitot-static system, is going to be the VSI, which is a vertical speed indicator. Works kind of like the, almost exactly like the altimeter, except for the fact that it has a leak in that little airbag in it that is very, very calibrated to where it will give you the speed that you are ascending or descending in thousands of feet per minute. And so it works as the same thing. It gets static air at a very slow rate. So next, we're going to talk about the gyroscopic system. Now this one is a little bit more complicated, it can be, but it just runs on gyroscopic rigidity in space. The 3 instruments that runs on are going to be your attitude indicator, your directional gyro, and your turn coordinator. These 3 instruments, again, they all run on the the concept of gyroscopic rigidity in space. So your attitude indicator is one of the most important instruments that you have. It is kind of like an artificial horizon. You can imagine, you can kind of see over here that the brown part of it is going to be like the ground, and then the blue part is the sky. If you can't see outside the aircraft, you can use that as a quick reference of, hey, am I at a nose level attitude, or am I nose down or nose up? It will also indicate a turn. This is run off of air that is being pulled through the instrument by a vacuum pump run by the engine. So that is an extremely important instrument, especially during instrument flight. The second one is a directional gyro. Now this kind of looks like a compass, right? If you just look at the dial, it's not a compass. It is extremely important that it doesn't run on the magnetic properties that a compass does, because in an aircraft you're required to have a magnetic compass, but it is not necessarily accurate, the reading of a compass. According to the U.S. Department of Transportation's 2012 revision of the Instrument Flying Handbook, the magnetic dip and the force of inertia causes a magnetic compass error when accelerating or decelerating on an easterly or westerly heading. Basically, that means if you are increasing your throttle and going faster, your compass is going to read an inaccurate statement. This will not. This will be an accurate statement regardless of the orientation or speed of the aircraft. You do need to align it with your magnetic compass, though, to make sure that it doesn't get off. Finally, we have our turn coordinator. This one's a little bit more simple. It's the only one that's run with an electric motor. It basically shows you whether you're at standard rate, which standard rate, all that means is that if you turn at that rate, you will make a full 360-degree turn in 2 minutes, which is important for sequencing and stuff like that in an aircraft. And then it shows this little ball here, shows whether you are skipping or skidding, which is basically just when the tail of the aircraft is outside or inside the rate of turn. So if you're turning too fast or not fast enough, you use gyro or rudder input to correct for that. So hopefully, in conclusion, this is how the 6 primary instruments run on 2 primary systems inside of a plane. Hopefully this gives you a little bit more insight next time you're on a trip as to kind of what's going on up in the cockpit of an aircraft.